Hi everybody, this is Mr. Garb here. I'm doing a retake on the Solving Exponential Equations Homework 12. I started going over the other homework by mistake, and then I came back and did it later, but some of you may not have seen the second Zoom there, so I'm doing this to recap on the homework there. So I divided by 3 on both sides here, and I got this expression right here. And then after that, you might be familiar with taking the log base 2 of both sides, getting x minus 4 on the left, and you'd get log base 2 of 0.5 over here. You could do that as well. However, I want to make sure you understood that if you take log of a to the b, that's equal to b log a. You can bring down that exponent and put it in front. And that's the way I did it here. So bring down x minus 4 log 2 is equal to log of 0.5. And then when you do that, you divide both sides by log 2. And you get x minus 4 equals log of 0.5 over log 2. And you add the 4, and you can get 3 this way, or you could get 3 this way also. I want you to know that 0.5 is really equal to 2 to the negative first power. And you might ask, why would I want to do that? Well, if you get the same base right here written to an exponent, then these exponents are equal to each other. So if you have 2 to the x minus 4 and 2 to the negative 1, x minus 4 is equal to negative 1, so x is equal to 3. So in either case, you get x is equal to 3. There's more than one way to do the same problem. I just want to make you guys aware of that, but it's 3 in either case. Number 2, so that rule, the second rule there is if you have the bases the same, then the exponents are equal. So it's very effective to rewrite an expression using the same base. If you saw that 2 to the negative 1 is equal to 0.5. That's really helpful to do that in a lot of these logarithmic expressions. So right here, you're going to have 4/5 times 5 to the 3x plus 7 equals 11. So in this case, I subtracted the 7 first. I got 4. Then I multiply both sides by 5/4. Multiply both sides by 5/4 right here. Okay. And then I got 5 to the 3x is equal to 4. And then you're at the same situation again where you have 5 to 3x equals 5. Now notice that you have the same base. I don't know if you were taught that before, but if you have the same base here using this rule, a to the b equals a to the c, then b equals c. Therefore 3x equals 1, and you could solve it right there. If you didn't notice that, then like I said, you can bring this 3x down, okay, make it 3x log 5 equals log 5. That's taking the log of both sides. Then you get 3x is equal to 1 and x equals 1/3. So in either case, the answer is going to be 1/3. Number 3 here, if I got you, okay. So I'd subtract the 1 first, and then you get 10.04 is equal to 1/2 e to the x minus 5. And then I'd multiply both sides by 2. So I multiply both sides by 2. And I get e to the x minus 5 equals 20.08. All right. And then from there on, I would take the ln of both sides, the natural log of both sides. So that means you bring down the x minus 5 times the ln of e equals the ln natural log of 20.08. So that's that rule again. When you're taking the log, or you might have learned this in class, that you take the ln of e of both sides. This is really saying the same thing. You take the ln of e of both sides, then ln base e, then you're going to get x minus 5 alone, and you're going to get ln of 20.08 here. In either case, you're going to be left with a situation where you're going to add 5 to both sides, and you have x equals 5 plus ln 20.08, and that comes out to about 8, because this is about 3 right here. So you should get x equals 8 approximately. And the last one here, number 4, you're going to add 8 to both sides, and if you add 8 to both sides, you get a 1, so you get 10 to the negative 2x plus 5 equals 1. So if you do that, you're going to get 10 to the 0, so you get 10 to the 0 here, and you get 10 to the negative 2x plus 5 here. So if you're able to see that 1 is equal to 10 to the 0, then you could see that these bases are the same, and then you could equate negative 2x plus 5 equal to 0, and then you could solve, and you can get x equals 5/2. If you don't see that, again, you do that rule where you take, you might say take the log of base 10 of each side, but I'd like to say use the power rule, so take the log of both sides, bring the negative 2x plus 5 down. See this? Same rule I've been using both times. Log of a to the b equals b log a. Okay, so you bring this down, and then you're taking the log of both sides. And if you do that, then you get the log of 1 on the right, which is 0, and log of 10 is 1, so it's really just negative 2x plus 5 equals 0, and you get negative 2x equals negative 5, and you still get x equals 5 halves. So in either case, the answer is 5 halves. So to recap, the answers are 3 and 1/3 for those two right there, 1 and 2, and 8 and 5 halves. And I did post these answers online as well, but I just wanted to give you a little video explanation of that. So email me if you have any questions. I'm sorry, I know the schedule now. Hopefully that'll never happen again. It was an odd scenario where I have two similar assignments the first time through. So I'm sorry for any confusion. Reach out if you have any trouble. Thank you so much. Bye now.